Hello class, today we're going to be looking at section 2.5 called Zeros of Polynomial Functions. We'll first start off by saying an nth degree polynomial has exactly n zeros, including the complex numbers. So what does that mean? Well, let's look at this page just real quick. The exponent here, the degree of this function is just 1 because the exponent's 1. So it has exactly 1 0. This one right here, the degree of this one is 2, so it has exactly 2 zeros, and 3 and 4. Okay? So that just tells you how many zeros that you can possibly have. So let's look at the first example, which is kind of an easier one. When you want to find the zeros of the function, all you do is set it equal to 0. So x minus 2 equals 0. So obviously that is just x equals 2. And that's just the simple answer there. That goes way back to your Algebra 1 stuff. Okay? So let's step it up a little bit to example number 2. It says x squared minus 6x plus 9. Well, what we want to do is always you want to see if you can factor these things out. Okay? And this one happens to factor out. Hopefully you remember how to factor. X and x factors of 9 that you can add to get to 6 would be 3 and 3. And you get to a negative 6, so it would be a negative and a negative. Okay? Now you can either write it like that, or you could write it as x minus 3 squared. It works either way. Doesn't matter which way you do it. As you can see, you can get your two answers from here. Okay? Because if you set one factor equal to 0, you get x equals 3. Okay? So that's x equals 3, and of course if you did this one, it would be the exact same thing. Okay? So x equals 3 is your answer. Now you said, well, before there was two answers. Well, just the 3 repeats itself. So it'd be 3 and 3. You really don't need to list it twice. All you need to do is just list it one time. Okay? So now, going on to example number 3, we have x cubed plus 4x. Okay, I look to see, can I factor out anything that's common between those? Well, the x, I can factor out an x between both of those. So if I factor out an x, I'd have x and x squared plus 4. Now the x squared plus 4 is almost the difference of squares, but not quite, because it's a plus instead of a minus. So that's as far as you can factor it. So now what we have to do is set each factor, just go ahead and set it equal to 0. So this one's already solved. X is 0 is an answer. Okay? And then you do here x squared, subtract the 4. And then how do you get rid of the square? You take the square root. Anytime you take the square root, what always goes in front? Yes, that is right. A plus and a minus always goes out in front. Now it's square root of a negative 4, so square root of 4 is 2, but it's a negative, so it's got to be 2i. So it's a plus or minus 2i. So if you want to list it out as like that, or you can just list it as 0 plus or minus 2i, either way would work. Okay. Now, if I just ask you for the real 0, it'd only be the 0. If I ask you for all of them, which is what we're doing, it's got to be the real and the imaginary altogether. And again, we knew there's 3 answers, so there's 1, and that's 2 and 3. So total possible of 3 possible solutions there. Okay. Moving on to example 4 to finish off this page here. X to the 4th minus 1. Well, that is the difference of squares, because I can take the square root of x to the 4th would be x squared. And the square root of 1 is, of course, 1, and a plus and a minus. Okay? Now look to see, can I factor those things out any further? And again, I have the difference of squares right here for this first guy. So that's x plus 1 and x minus 1. So if I was to factor that out all the way, we would get that right there. So now we've factored out as far as we can, so we just set each one equal to 0. And x squared plus 1 equals 0. So once we've done that, you just solve each one. You get x equals a negative 1. X equals a positive 1. And soon you'll get the hang of being able to solve these real quick without having to show much work. So take the square root of both sides, and do not forget what most people forget, the plus or minus out in front. The square root of negative 1 is just I. So you have plus or minus I. Okay. So now let's go on to the next page. Okay, now we're going to move on to example number 5, which here starts to get to be the interesting, long, complicated part of this lesson. Factoring a polynomial. Find all the zeros of this long function given that 1 plus 3i is a zero of that function. So let me just start off by saying, let's say like if x equals 5, let's just do an example other than this right here. X equals 5. If I was to say that was a zero of the function, could you tell me what that factor is? Well, that factor, you've got to set equal to 0, right? So you just move it over and you say, well, x minus 5 would be that factor that would factor into that polynomial. Okay? So we're going to keep this in mind when we're looking at this problem here. Okay? 1 plus 3i is a 0. So if I set it up as 1 x plus 1 plus 3i is the, that's equal to each other. Okay? If that is the 0, I would say the factor would be, let's get that equal to 0. So it would be x minus 1 plus 3i. That would be the factor of it. Okay? If that is the factor, now keep in mind, everything comes, the complex zeros occur in the conjugate pairs. So if 1 plus 3i is a 0, then 1 minus 3i also has to be a 0. So if I did the exact same thing, 1 minus 3i has to be a 0. So if I set that equal to 0, it'd be x minus 1 minus 3i. Okay? So if I was to write it out as a nice big complicated thing, I could say this and this both go into that. So let's figure out what happens when I multiply these guys together to see what it is that can be divided into that. So we can do our long division. So this looks really, really bad and messy. Okay? I know it's going to look really weird the first time you do this. It looks weird every time I still do this because it seems so complicated. But it is the only way that it can be done. Okay, so I have to multiply these guys together. Okay? Now instead of doing it this way, I'm going to kind of just rearrange, group my things together a little bit different. Remember that negative's got to be distributed to both. So I could write it like that. I'm going to put those in groups now. And if I do the same thing over here, minus and minus is a plus 3i. I'm going to put those two guys together. So now if I do that, the difference of squares, because one's a plus and one's a minus. And these are things that we're going to square because it's the exact same thing. So this is going to turn into x minus 1 squared minus 3i squared. Okay? So remember when we do x minus 1 squared, make sure you don't just do squared and squared, make sure you multiply it out. Or if you remember the shortcut, like we said we're going to start doing more often, x squared minus 2x plus 1. Now this you can just square and square. Okay? Remember I squared is a negative 1, the square root of a negative 1 squared, which would be a negative 1. So this right here turns into a negative 1. And then times that by 3 squared, which is 9, so that times it by negative 9, so that'd be negative and negative is a positive. So we have that right now. So if I combine my like terms, I did all this, really haven't solved a whole lot of the problem yet, but this gets us really started with the problem. Excuse me. So now I can take this right here, and I know that's what can be divided into this big mess. Because I can't really divide it by a plus 3i and a minus 3i because it's imaginary. Okay, but I know that this can be divided into that. So what we want to do now is simply take that, divide that into the big long mess there, x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. Okay, so my paper set up there. So we go through the process. X squared times what is x to the 4th? That would be x squared. Multiply those to everything, that'd be x to the fourth. X squared times a negative 2x is negative 2x cubed. And end that off with a 10x squared. We subtract next, so I'm going to go through and just change all those signs so I don't forget. That's a minus. So those goes to 0, and negative 3 plus 2 is a negative 1x cubed. 6 minus 10 would be a negative 4x squared. Drop down the 2x. So we do x squared times what is a negative x cubed. That would be a negative x. So x times all that would be a negative x cubed, a positive 2x squared, and a negative 10x. When we subtract, change all the signs. That would be a 0. Negative 4 minus 2 is a negative 6x squared. 2 and 10 gives you 12. Drop down the 60. Now, when we get to the final end here, since we know there's a factor, our remainder better be 0 or something's gone wrong. Okay, so x squared times what is a negative 6x squared? Of course, is a negative 6. So a negative 6 times all those and get you to that. So of course when you subtract that, they're all the same, so your remainder does go to 0. So we know we've done this long nice part over here, we've done that correct since our remainder is 0. Okay, so it says find all the zeros. So what we've done right now is we haven't quite got that answer yet, but we're getting really close. Okay, so we know that the zeros here, okay, this is what we have left once we divide that into there. So we have x squared minus x minus 6. So can we factor that out a little bit further? Yes, we can. And that goes to x minus 3 and x plus 2. So what we have there is x minus 3 equals 0, x plus 2 equals 0. So of course we get x equals 3 and x equals a negative 2. Now keep in mind, we already had one 0 from up here. Okay, these are two zeros that we've listed from what we had left here. And don't forget our 1 plus 3i. And then of course its pair would be 1 minus 3i would be the other two. So remember I said find all the zeros, so we could have at most 4 zeros. They give us one there. So we know the conjugate, we know those are two zeros automatically. We took that and figured out what can we divide our polynomial by. So we did that, then we factored out what we had left to get the other two. So we had 2 reals and 2 imaginaries to get our final answer there.